In this section, we're going to be talking about conic sections. So the first conic section that we want to talk about is a parabola. So a parabola is the set of all points in the plane that are equidistant from a fixed point f called the focus and a fixed line called the directrix. The midpoint of the line segment connecting the focus and the directrix is called the vertex. So if we look at our diagram here, what we're talking about is our directrix is our line down here, and the focus is a fixed point in the plane right here. And so we're talking about the equidistant point, so from the focus to the point P, this distance is going to be the same as the perpendicular distance from P to the directrix. So for any given point. So we have another one going on over here. So we would have this line segment here would be the same as the length of this dashed line segment here. So that's our geometric definition of a parabola. So the equation of a parabola with its focus at the point 0, p and directrix y equals negative p is given by x squared equals 4py, and the equation of the parabola with focus p, 0 and directrix x equals negative p is y squared equals 4px. So the parabolas of the form x squared equals 4py are the type of parabolas that are going to open up and down, the ones that were like our traditional functions. And then we're going to have parabolas that open right and left, and those are the ones of the form y squared equals 4px. So whether our directrix is horizontal or vertical is what determines whether a parabola opens up or down, or right or left. So let's take a look at our first example. So it says, find the focus and the directrix of the parabola y squared equals, or y squared plus 10x equals to 0. So the first thing we note is that this, since it has a y squared, is going to be like this. So we need to put it in that form by minusing 10x from both sides of the equation. And that gives us y squared is equal to negative 10x. And we want to compare that to y squared is equal to 4px. So then this tells us that negative 10 has to be the same as 4p. So that gives us the equation 4p is equal to negative 10. We divide by 4, we divide by 4. And that gives us that p is equal to negative 5 over 2. So if p is negative 5 over 2, and we know that we're using this form of the parabola here, we know that our focus is going to be at negative 5, 2, 0, and the directrix is going to be at x equals negative p. So that gives us x equals a negative 5 over 2. Or in other words, x is equal to 5 halves. Okay, so now it's your turn. So have you go ahead and do your U try. So same instructions. Find the focus and the directrix of the parabola x squared minus 8y is equal to 0. So this parabola is of the other form. So we were using this one, but now we're going to have our focus at 0p and our directrix at y equals negative p, and our standard form is x squared equals 4py. So doing the same thing, we add 8y to both sides, and that gives us x squared is equal to 8y. So we compare that to x squared equals 4py. So we get that 4p has to be the same as 8, so we divide by 4, and that gives us that p is equal to 2. So the focus is at 0, 2, and the directrix is at y equals negative 2. So the next conic section that we wish to talk about is the ellipse. So the ellipse is a little bit different than a parabola. Once again, we're going to talk about the geometric definition. So an ellipse is the set of points in the plane, the sum whose distance from two fixed points, f1 and f2, is constant. The two fixed points are called the foci, or singularly each one is a focus of the ellipse. So in this picture, we have these two different distances, and they're not the same, obviously, but the sum of those two distances, so if we call this distance d1 and we call this distance d2, then the sum of those two distances, d1 plus d2, equals a constant for every point P on that ellipse. So the ellipse of the form x squared over a squared plus y squared over b squared equals 1, when a is bigger than b is bigger than 0, has foci at plus or minus c, comma 0, where c squared is equal to a squared minus b squared, and vertices plus or minus a, comma 0. And the major axis is the one that is parallel to the x-axis. Similarly, if the larger number is under the y variable, then we would write our ellipse as x squared over b squared plus y squared over a squared equals 1. And it's going to have foci at 0 plus or minus c, where c squared is still a squared minus b squares, and our vertices this time are going to be on the y-axis at 0, comma, plus or minus a, and the major axis will be parallel to the y-axis. Alright, so let's go ahead and sketch a graph of the following ellipse. So we have 9x squared plus 16y squared equals 144. So to get our graph into one of these forms, we'll notice that in both of these, and we don't know which one we have yet, the constant on the right-hand side is always the number 1. So if we have 9x squared plus 16y squared is equal to 144, we need the right-hand side to be equal to 1. So we are going to divide all parts of this equation by 144. So after doing this, 9 and 144 reduce to give us x squared over 16 plus y squared, 16 goes into 144 9 times, is equal to 1. To help us get back in this form, we'll notice that the denominators are perfect squares. So in this case, 16 is a perfect square. So we have x squared over 4 squared plus y squared over 3 squared is equal to 1. So then the larger number in the denominator is under x, so that's going to be our a, and this is going to be our b. So when we have a is bigger than b is bigger than 0, the larger number is under the x. That means that our major axis is going to be parallel to the x-axis, and we're going to have our foci at plus or minus c comma 0, where c squared is equal to a squared minus b squared. So let's get our quick sketch. So if this is our a value, then that means that we are going to have the points plus 4 and minus 4 for these guys. And for b, we're going to have plus 3 and minus 3. And then if we draw our ellipse, it's not half bad. That is our ellipse. So now we need to find the foci, and according to this, our foci are at c squared is equal to a squared minus b squared. So c squared is equal to a squared, so 4 squared minus 3 squared, which is 16 minus 9, which gives us 7. So that gives us that c is equal to plus or minus the square root of 7. So our two foci are at plus or minus the square root of 7 and 0. So to approximate, the square root of 7 is about 2.6. So that would mean our foci are going to be at about 2.6 and negative 2.6. And these 2 points would be our two foci, pardon me, for that ellipse. All right, it's now your turn. So please go ahead and sketch a graph of the following ellipse. All right, so once again, we need to divide everything by 100. And that gives us x squared over 4 plus y squared over 25 is equal to 1. And then recognizing that that's 2 squared and and 25 is 5 squared is equal to 1. So this is definitely going to be our larger one this time. So that's our A. And this is going to be our B. So since the larger number is underneath our Y this time, that means our major axis, or the longer axis, is parallel to the y-axis, or in this case it's on the y-axis. So we're going to have our 2 points at 5 and negative 5, and then our minor axis, we're going to be at 2 and negative 2. And if we draw our ellipse, we get something that looks kind of like this. And then our foci are still at c squared equals a squared minus b squared. So that's 25 minus 4, which is going to give us 21. So c is equal to plus or minus the square root of 21. So the square root of 21 is 4.58. So about 4.6. That means our foci are really, really close out here this time on our ellipse. All right, so the last conic section that we're going to talk about is a hyperbola. So when we had an ellipse, the geometric definition of the ellipse was that the sum of the distances from the foci to any point on the ellipse was constant. Well, a hyperbola is similar, but a little bit different. The hyperbola is the set of points in the plane whose difference, so instead of the sum, the difference, whose distances from two fixed points, f1 and f2, is constant. And once again, the two fixed points are called the foci. So then the hyperbola, x squared over a squared minus y squared over b squared equals 1, has foci at plus or minus c comma 0, where c this time is a squared plus b squared, and vertices at plus or minus a comma 0. It has a pair of asymptotes, and they are at y equals plus or minus b over a times x. So notice in this case, we don't have any relationship on which is bigger, like with the ellipse a or b. This time, it's which one of them is positive determines the axis on which the vertices and the foci are. So with the hyperbola y squared over a squared minus x squared over b squared equals 1, its foci are still at c, but they are now on the y-axis, and the vertices are also on the y-axis. And notice that now the asymptotes are y equals plus or minus a over b times x. So let's go ahead and do example number 3. So find the foci and asymptotes of the hyperbola and sketch the graph of 9x squared minus 16y squared equals 144. So like we've seen in the previous problems, we need to get 1 on one side of the equation. So we're going to divide everything by 144. 9 goes into 144 16 times. And 16 goes into 144 9 times. So that gives us the equation x squared over 16 minus y squared over 9 is equal to 1. Okay, so now, once again, 9 and 16 are perfect squares, so we get 4 squared, and 9 is 3 squared over 1. So since our x term is positive, that means our major, or our foci, and vertices are going to be on the x-axis. So this guy is our A, and this guy is going to be our B. So we're going to have our vertices are right here at plus or minus 4. And our foci are c squared equals a squared plus b squared. So in this case, that's 16 plus 9, which gives us 25. And 25 does have a very nice square root, which is exactly 5. So our foci are going to be at plus or minus 5. So now we know that our asymptotes, since we are in the first case here, are y equals plus or minus b over a. So we're going to have our asymptotes as y equals plus or minus, and then our b is 3. So we're going to get 3 over 4 times x. So up 3 and over 4. So we go up 3 and over 4, left 3 and down 4. Ah, that was terrible. Let's see if I can. So down 3 and over 4. All right, let's see if I can connect the dots a little bit better. There we go. So that's our first asymptote, and then our other one, negative 3 over 4, down 3 over 4, left 3, up 4, and I did that backwards, so 4 and 3. And that gives us our asymptotes. So if we were to now try to graph this thing, we know it's going to come in on the asymptotes, go through our vertices, and then turn around and do this. So similar, it's going to come around and it's going to do something like that. So that would be a graph of our hyperbola. All right, it's your turn. Once again, we need to get 1 on one side, so we divide by 100, divide by 100, divide by 100, and that gives us x squared over 4 plus, and I have a typo, I just saw that. That is not a hyperbola, so this needs to be a negative, so minus 4 goes into 125 times, minus y squared over 25 is equal to 1. And that gives us x squared over 2 squared minus y squared over 5 squared is equal to 1. So we get, this time, that our A is 2, and we get that our B is 5. So if that's the case, then our foci are at 2, and our vertices are at 2 and negative 2. And we would have c squared is equal to a squared plus b squared. So that's 4 plus 25 gives us 29. And that c gives us plus or minus the square root of 29. So the square root of 29 gives us 5.38, so about 5.4. So then our foci are going to be at 5.4 and negative 5.4. And our asymptotes this time are still going to be our b over our a. So we get y equals 5 plus or minus 5 over 2x. So we go up 5 over 2. Similarly on this side. And then when we play connect the dots, we get a very mellow looking parabola. our hyperbola looks like this. All right, let's take a look at our next one. So find the foci in the equation of the hyperbola with vertices 0 plus or minus 1 and asymptotes y equals 2x. Alright, so let's draw a sketch and see what we can come up with. So we have our hyperbola, and we know our vertices are at plus or minus 1. So 0 and 1 and 0 and negative 1. So that means our parabolas, or our hyperbola, is going to open up and down, and we know that its foci are going to be on the y-axis. So we know that the foci are at c squared equals a squared plus b squared. But we also know that the vertical asymptotes are at y equals plus or minus, and if we have this form, so since we are on the y-axis, we know it's going to be y squared over a squared minus x squared over b squared equals 1. So we still have this, but our asymptotes have the form y equals plus or minus a over b x. It's going to be a over b x, and we know that we have y squared minus x squared is equal to 1 with a underneath the y. So if that's the case, we're trying to figure out a over b. So according to this, we know that a over b has to be the same as 2. So we have a divided by b is equal to 2 implies that a is twice the b value by multiplying both sides of that equation by b. We also know that the vertices tell us what our a value is. So if that's the case, we know that this is at 0, comma a, negative a, and this is at 0, comma a. So putting those two things together, we get a is equal to 1. So if we have a is 1, then we know that b has to be 1/2. So then the equation is going to be y squared over 1 squared minus x squared over 1/2 squared is equal to 1. And that would be the equation of our hyperbola. Alright, let's take a look at our next example. So 5 says, find the equation of the ellipse with foci 2, negative 2, and 4, negative 2, and vertices 1, negative 2, and 5, negative 2, respectively. So let's use the graph that was provided to do a little bit of a sketch to help us out. So our foci are at 2, negative 2, and at 4, negative 2. Our vertices are at 1, negative 2, and 5, negative 2. So we have an ellipse that looks like this. So all of these are on the major axis. So our major axis is going to be right here, and the length of the major axis is going to be this distance from here to here. So this is the length of the major axis. So 1, 2, 3, 4 is the length of our major axis. So at the midpoint right there, this has to be the midpoint of the major axis. So that's going to be quote-unquote the center of the ellipse. So we know that c squared is equal to a squared minus b squared for our ellipse. So let's go back and look at this. And we know that the foci are located at 0 plus or minus c, and the vertices are at 0 plus or minus a. But that was when in this diagram we had our center located at 0, 0. Well, in the example we're doing, we've shifted everything away from the center. So our center point down here has been shifted to the point 3, negative 2. So our equation of our ellipse is going to look like x minus 3 squared over a squared plus y minus a minus 2 squared all over b squared is equal to 1. So what we did is we took our equation of our ellipse here, and we knew that our major axis was parallel to the x, so we had this form, but instead of being centered at 0, 0, we shifted via composition both the x and the y to the new point. Well, if we do that, it's going to shift the foci and the vertices to those points as well. So we had plus or minus c, comma 0, and plus or minus a, comma 0. So these are going to be shifted by those values as well. So we'll notice then we have our foci and our vertices here. So our a value was the distance from the center of the ellipse to the vertex. So that's going to be this distance right here is a, and this distance is a. So in our case, we identify that our a is equal to 2. B, we don't know. That's on the minor axis. But we do know c, and c is the distance from the center to either one of these values. So this is going to be our distance c, and this is going to be our distance c. So we get that c is equal to 1, and we know then that c squared is equal to a squared minus b squared. So 1 squared is equal to 2 squared minus b squared. So that gives us 1 is equal to 4 take away b squared minus 4 and minus 4. We get negative 3 is equal to negative b squared. Divide by negative 1, divide by negative 1, and we get b squared is equal to 3. Taking the square root, we get b is plus or minus the square root of 3. So now that we know b, we could plot our two other points on our ellipse. So the square root of 3 is 1.7-ish, so 1 and 0.7, 1 and 0.7. Oops, I did not put them at the center, which is here, 0.7, and that would give us our ellipse. So finally, putting all of that together, we get the equation of our ellipse is x minus 3 squared over our a squared, and a is 2, so 4, plus y plus 2 squared, all over the square root of 3 squared, which is 3, is equal to 1. And that's going to be the equation of our ellipse. Alright, so let's go ahead and look at our last example for this section. So we want to identify and sketch the conic given by 9x squared minus 4y squared minus 72x plus 8y plus 176 is equal to 0. So what we need to do is complete the square. So we're going to gather all of our x terms together, and then we are also going to gather all of our y terms together. And then we're going to move that constant to the other side by minusing 176 from both sides. That gives us 9x squared minus 72x, leaves some space, minus 4y squared plus 8y is equal to, leaving some space, negative 176. So we're going to complete the square on each of these pieces. So we factor a 9 out, and that gives us x squared minus 8x. And so we take half of our b term and we square it. So half of 8, or of negative 8 is negative 4. Negative 4 squared is positive 16, so I'm going to add 16 and subtract 16. I'm going to do the same thing over here, so I factor out my minus 4, that gives me y squared minus 2y, and I leave some space. And I have my new b term is negative 2, so negative 2, half of negative 2 is negative 1, negative 1 squared is positive 1 minus 1, equals negative 176. So now we factor the perfect square trinomial that we made in each of these. And that gives us 9 times x minus 4 squared minus 16 minus 4 times y minus 1 squared minus 1 is equal to negative 176. And then we open our parentheses by distributing, and we get 9 times x minus 4 squared. 9 times negative 16 is negative 144. Distributing in the minus 4, negative 4 times y minus 1 squared, and negative 4 times negative 1 is positive 4. And then that is equal to negative 176. So we gather up our like terms. So negative 144 plus 4 is going to be negative 140 minus 4 times y minus 1 squared is equal to negative 176. So we move our constant to the other side of the equation, and we get negative 36 is equal to 9 times x minus 4 squared minus 4 times y minus 1 squared is equal to negative 36. So to put this in standard form, we need to divide all terms by negative 36. So then when we do so, negative 36 divided by negative 36 is 1. And a negative divided by a negative is positive, and 4 goes into 36 9 times. So I'm going to write my y term first. So y minus 1 squared over 9 minus, because a positive divided by a negative is a negative, and 9 goes into 36 4 times, x minus 4 squared over 4 is equal to 1. So finally we get y minus 1 squared over 3 squared minus x minus 4 squared over 2 squared is equal to 1. And we identify that this is a hyperbola, and the hyperbola has center at 4, 1, and we know that c squared is equal to a squared plus b squared. So we have c squared is equal to 3 squared, so 9, plus 2 squared, which is 4, which equals 13. So we get c equals plus or minus the square root of 13. And we have that our asymptotes are at y equals plus or minus 3 over 2 x. Alright, so now we want to sketch this thing, so let's grab a graph. So our center is at 4, 1, and our major axis is going to be parallel to y, because our y term is positive, and our foci are going to be up and down 3 units from there. So up 3, down 3, those are our foci, and then the square root of 13 is going to give us our foci, and the square root of 13 is 3.6. So up 1, 2, 3 and 0.6, up 1, 2, 3 and 0.6, and then we have our asymptotes. We're going to go through our center with slope 3 over 2. So we go up 3 over 2, and by some symmetry we get something like this. So then hyperbola is going to look something like this.